This small spinning tool has quietly shaped the modern world, from the phone in your pocket to the engine in your car. But where did it come from? In the early 1800s, machinists shaped metal using simple rotary cutters that could only cut on their sides. Cutting into the face of a material, plunging downward, was nearly impossible. That limitation held manufacturing back for decades. The breakthrough came in the mid-1800s when toolmakers began designing cutters with teeth not just on the sides, but on the end face too. This allowed the tool to plunge directly into material and cut in multiple directions. These early end mills were made from carbon steel, hand-ground by skilled toolmakers and used on manual milling machines to produce rifle components and industrial parts. The early 20th century brought a major upgrade: high-speed steel, or HSS. Developed around 1900, HSS end mills could cut at far higher speeds without losing their edge from heat. During both World Wars, HSS end mills became critical, mass-producing weapons, vehicles, and aircraft parts at a scale never seen before. After World War II, tungsten carbide end mills entered the scene. Carbide is dramatically harder and more heat-resistant than HSS, allowing cutting speeds up to 10 times faster. Combined with the rise of CNC machines in the 1970s and 80s, carbide end mills unlocked a new era of automated, high-precision manufacturing. Today's end mills are engineering marvels. They're coated in ultra-hard materials like titanium nitride and diamond-like carbon to reduce friction and extend tool life. Computer-optimized flute geometries, variable helix angles, and nano-grain carbide substrates allow modern end mills to cut hardened steel, titanium, and exotic aerospace alloys with extraordinary precision. From a hand-ground carbon steel cutter in the 1800s to a nano-coated carbide tool guided by a computer, the end mill has come a very long way.